On this channel, we build a game from scratch using Love2d and Lua. We are building a top-down adventure game filled with magic, music, and adventure. So let's take a look at what we did yesterday, and we will do that like this. Run Love. We've got our gecko entities going in different directions, so that's good. Now what we're going to be working on today is setting up a map collidable object. So it's going to be our map here, like we know what pictures we need to render for whatever current scene we're on, right? So we've got, like, you know, if it's a map 2.2, it's currently all these blue bricks. If it's a map 3.2, you're in the movie Dune. But we need each scene to contain a reference of all the collidable objects in the scene, so that we can check collision detection against our player, so that we can't walk over a tree like this, because we need to decide, hey, in map 1.1 there's a tree in the bottom left, so we need to give a collidable object where the tree is. And we could do it based on the tile. I think that might be a little tougher than is going to be useful, but we might do it smart like that, or we might just try to get it to work and then go from there, which is normally my approach to things. So yesterday we tried to do it based on our entity system, and that didn't work because our entity requires an animation. And this just needs to be an object. So what we can do is just make a new class called, like, global map collidables or something. And then that will have, and you know what? We lost our desktop audio here. Let me get that back. We disabled it, and then we didn't enable it here. Boy, bear with me. Yeah, we just try to get our desktop audio back. We need to active. You know what? I'm not sure how to get it back here. Yeah, we're missing our desktop audio. Let me just... Nothing like being on the spot to try to figure out some tech stuff like this, you know. It says they're all active, so I don't know what's going on. Let me add a source called okay. Is it back? We got music back? Hopefully. It's looking like it. Okay. We're ready to go. We good. Okay. Yeah, that screwed me up, and now I've got those files all locally on my machine, not on my flash drive anymore. We do need to get our bash script, or not our bash script, our bash RC shortcuts for Git set up again. I'm curious if we have that on our flash drive here. And then another thing I want to do is test. Yeah, we don't have our bash profile, so I'll do that off stream later today, because we used to have it set up where we could do a git get A for get add and commit with a message. Nice bomb, dude. That was sick. So yeah, I think it costs 10 gold for the other skins of your cap. So there's that. And then I was also thinking once we hit affiliate, we can get channel points, and then we can have a channel point redeem to get a custom skin. So like if someone likes a certain Pokemon and they want the shiny skin of it, we can be, oh, does it really? Oh, I think I cost it down. Should I make it cheaper? I think I can cost it down. Because I was kind of thinking maybe just 1 gold maybe? So it's not free, but it's not like a big deal. Okay. Well, and I think can you bomb other people? Can you bomb people with it by saying like bomb findingfocus.dev? Can you do that? Let me see. Okay. For me, it's free. Okay, that's cool. Okay. I did add a shiny Gyarados manually, but I tried adding different Iron Man skins and I ruined all the Iron Man skins, so I had to uninstall and redo everything. But anyways, let's get going here. That is one thing about the stream avatars, is pretty distracting, but it's just so much more fun. So I think it's fine. Okay. I think we're gonna do... I do want to see if we can get leader M back. So I'm curious if we used to be able to run our game just by pressing leader M, but right now that just does this and it's not very impressive. So I think I'm curious if we can exit our bash within here. Oh, that just quits. Damn it. I thought that might open in Windows PowerShell, but I guess that makes sense that it wouldn't. And exit, yeah, let me see. Because I'm thinking if we get, yeah, I'm not sure it can work like that. Shit. I'm really wanting that back because it's a pain to go switch it with 2 buttons and then type Love2d and run our game. So I do want to figure out how to switch it back, but it's not so easy. Okay, let's get started here. We're gonna be... I guess the first thing we want to do is just take a look at our scene and see if there's any sort of way that sticks out that we can add a map object collidable to our scene. So it's like our scene is the thing, and you know what? It might be to our map. We might need to add it to our map instead of our scene, because our scene has a reference to our current map. So if we have it in our map, we have it in our scene, but then we would need the next map anyway once we do a transition. I guess it doesn't really matter for collidable objects during a transition, so let's see. We lost our blinking cursor. Why is that a thing? We've got it over there. Yeah, you know, I haven't been... Windows is nice because we can do certain stuff like stream avatars and stuff, but I really don't like the Windows PowerShell. The stable streaming is nice, so we'll stay for that, but I do wish it was better. Like, why is our blinky cursor not blinking? It shows it here blinking like an example. It might be in our config here. screw it. We're just gonna have a not blinky cursor, I guess. It kind of bugs me though. Yeah, it's like we don't even have it here. It's little things like this that just drive me crazy. Let's try it again. You know what? I just killed our chatbot. We gotta run that first. We run our chatbot here because it's in our Windows directory, so we're just going to go into our chat directory and run our chatbot JavaScript file. And we should be back. Okay. So yeah, just some growing pains, not growing pains, but growing pains to get this stuff back to where we like it. So for here, we will do bash. We'll do our tmux attach. Okay, then we need a new page for our love running. Okay. Okay. Yep, our blinky cursor is just gone. I don't know why, but it doesn't matter. It's just annoying me. All right, let's take a look at our map class. So a map has a table of all the tiles. Yeah, I think this is where we want to do it. So I think what we want to do when we init a map. Now, I guess we need to also see how this plays in with our scene transitions, because we pull, like, do we init the map? Yeah, we init a map upon a transition. So once we init the map, we'll have to pull its corresponding collidable objects for that map. So we don't want to just put it in our map class init, because these objects depend on what map we're actually pulling from. So how do we do this? We can have a corresponding 2D array of map object collidables, and we, just like our map declarations, we put it all there, and then when we init our map, we go through at that exact index we need it, like this. See, we cycle through the map height and width, and we insert the map at the row and column of our... Okay, let me see here. This is... Can't tell if that's loading our default tile set. Okay, so yeah, we don't actually render the real... Okay, so this is... We are doing it different. Like, this is actually just doing, what is this doing? Now, I think our map, our all caps map, is our map declaration here. Yeah. For the whole global tile set. So I can see it. I can see us adding our objects to like to be another piece of this index, or we just have a corresponding map objects that maps to the same numbers. It's hard to say though, because we want, ultimately when we're doing the level design, we want to be able to say, hey, this is a tree stump, you know, right here in the top left. And then ideally we would say, hey, tree stump is a collidable, so cycle through and every tree stump in that list, add it to our collidable. Yeah, my brain's starting to break trying to think about it 3 steps ahead. Just trying to think of how we can kind of future-proof it, because we want it to be easy to develop, easy to add. When we map out a certain, say, tree stump, for example, we know that tree stump needs to be a collidable. So why would we waste our time with another separate table that we say, hey, we're going to hard code this tree here? Because if we dynamically change where the tree stump is, we'd have to go and change it in the corresponding map object. So I think we want to do this different. I think we do want to do a sort of and there, one thing we could do is like give, yeah, this isn't a bad idea. We can do we could assign, so like right now, let's take a look at our tile set here, and we'll see that our graphics tile set, it's just called map master sheet. Yeah, so we've got a master sheet here of different floors and stuff. Now, if we were to kind of designate that these bottom 4 rows are all unwalkable, so like there are map collidable tiles, so everything like trees or tree stumps or walls, fences, anything you can't walk over is going to be in these last 2 lines here. If we were to make that convention, then all we would have to do is say, if our tile, like we would go through, we would cycle through, oh, let me think this through. Because we have our map declarations, and these are all mapping to numbers. But just gonna see if there's a blinky neovim or something command we can do, because it's really bugging me that it's not blinking. Set GUI cursor blink on 100. Didn't work. I think it's a Windows thing. I'll try to figure that out. Okay, well, so this is a tough thing to try to figure out. Like, the collision detection by itself is easy, but trying to dynamically insert a collidable object based on the tile set isn't so straightforward. So I think we do want to spend a little more time and figure out how to do this, because it will be worth it, albeit tough. So how might we populate, like, every map needs to contain a reference to all of its collidable objects, X, Y, and width and height portions. So if we were to adopt a convention that would put all of our collidable tiles a bigger number than, let's say, you know, whatever our top or our bottom 4 columns are, we reserve those for collidable objects. Then in our map class, we can go map class here, when we initialize ourselves, we can go insert into a self.collidable map objects table and we need to make this class still. We need to make a collidable map class, or collidable map object class that has a x, y, width, and height, and we insert those objects into our table. We need, because if we have all those objects in the table, we can cycle through all the items in there and check for the collision for not only our player, but for our other entities. But we still need to be able to pull the X, Y, width, and height from only a tile ID given a current map. So I think what's possible here is, so when we init a map, we give it a row and column. So let's say it's at 1, 1 or whatever. Then we're inserting the count into the ID here. So I guess I'm curious why we have to assign an ID into our self.tiles table, because this is how we're actually rendering everything, because we're drawing based on the tile ID, and the tile is built from our self tiles table. Okay. Yeah. So I'm curious if there's a thing that we could end up doing that is like a self.collidable map objects. And it's an empty table, but we need to populate it with every collidable map object instantiation. So we do need to write a class for this, but we also need to populate this table with the actual values, hopefully only searching the tile ID, because we want it to be dynamic. We want when we define our map declarations here, we want when we say in here, hey, there's a tree stump, there's a tree stump, there's a tree stump, or there's a wall, there's a wall, there's a fence, there's a fence. We want to be able to say, okay, anytime there's any of those things, we're going to go insert that object into our collidable table object. That is what we're going to check for our collision detection. So I'm thinking like we could say, like, if the we would have to cycle through every row and column of our map after we assign it. And we would have to say, like, is that .id greater than, let's just say 1,000. We don't have this just yet, but if we do adopt that convention, it makes it a little easier to kind of determine whether or not a thing is collidable or not. And we don't have to do the last 4 rows. We could pick the middle 3 rows or something, but that's just something we'd have to decide. We could say, hey, if it's greater than 1,000, meaning if the quad is greater than whatever place we want to decide it begins our collidable map objects, then go ahead and insert that object into, we would insert our class object into this table that holds all of those object instantiations. And then our current map, which our scene has reference to, has a table of self-collidable map objects, and that could check our collision for any of those things that we shouldn't be able to walk over. That could work. Okay. I guess I'm kind of curious why we're doing... So here, for every map height, we give ourselves a tiles table, and then for every width, we insert into that index a map ID at index count. So what is this count? That's the index of of our tiles. So we're actually taking, so we're assigning. So effectively, this 3-dimensional array here will insert a number that is mapped to by our constants. So like, let's say we put in sand. Sand happens to be whatever number. It's going to pass in that number and assign it to the ID field of that self.tiles at the, this Y would be the row, not the column, but every subsequent one would be the next column over. Okay. So all this is doing is assigning whatever our map declarations tile ID into our self.tiles table. And our self.tiles table is how we're actually rendering the map. So what's really weird is our OBS is like, I have it kind of capped at 6,000 kilobits because that's what Twitch says, but it's all over the place. Like it went up to 7,000 or 8,000 and then been dropping. So I might need to look into that. This idea makes the most sense to me so far. So the hard part is realigning our sprite sheet to be quad specific for MapObjectCollidables, which I'm not so sold on. It's the easiest way I can think of to do it. And I guess it depends on how many, because what sucks is we don't have an idea. We don't actually know how many MapObjectCollidable objects we need for the game. So it's tough to say, hey, we'll just reserve all these bottom 5 rows as collidable objects. We might not need that many, or that might be... So that's why I kind of don't like it. So I'm trying to think if there's a different way we can kind of assign. Because ultimately, every tile ID, slots it up, dude. Every tile ID is a unique number. Hey, winner over here. It doesn't say, I guess if you use the extension, it doesn't say in chat how much you just won, huh? Or how much you bet. Okay, hey, that's pretty good. Did you win like 50 from that? I guess it depends on what you get. If you get bar is like a multiplier of like, it's the biggest multiplier. It's huge. So if you ever win on bar, it's going to be huge. So we do need... Hey, that's not bad. I made it an update so that the Pokemon legendaries are a lot more money. So if you were here yesterday, the Pokemon legendaries were only like 20, but now they're 100 or something. This is making the most sense to me to I think we do have to kind of keep track of it. Now we don't have to designate the very bottom of our tiles because we already mapped our other tiles down here, so we could do a little different. If we look at our master sheet table here, we do have... See, our tree is already on this one. You know what? What we'll do is we'll scoot up. See, and I don't like having to do this because we have to re-hard code it. We were supposed to be able to just place these and forget them. So you know what? Maybe we can move our tree up here to be beneath our map tiles up here. And what that can do is we can just designate, hey, these 2 rows of our map sprite sheet quads will be collidable objects. So then when we go to add collidable objects, we ask what the tile size is at that index, and if it's in this range of collidable object quad range, then we go ahead and add it to our collidable table object within our map. So I think that could work, and then we don't have to recode any of these, and we can just know, hey, these rows right here are all our collidable objects. So let's go do that. Let's move our master sheet and let's open it in A Sprite here. So we're going to move our tree here to be right below. It's a bad tree. We'll make a better one, but we want it to be right below these. And so now these two tiles here, like these two and all the way across, those will be our collidable object placeholders. So hopefully we won't need more than that 2 rows of stuff. I don't know if I like that because we're kind of limiting. Because we'll have like dungeon walls, we can have fence, we can have a post, we can have anything you can't walk over would need to be here. So maybe we give ourselves these 2 rows and all the way across, and then maybe that'll cover us. Yeah, I think we would need at least that. Yeah. Okay. So let's export this PNG, and we will say this is the same title. And then we will, let's run our Python script and we'll see what quad range this actually is. So let's go ahead and do that. We'll go over to our graphics. We gotta go CD into our graphics. I'm actually gonna do, CD graphics, and then if we run our Python 3, we've got to actually modify. We've got to modify our script here. We really don't have NeoVim in here, so see, I hate that we have to kind of split our system like that. I don't like that, but what we can do is CD into our graphics. Okay, there is our script. Now we can go into that Python script. Now we need to change. Okay, I like past us because we actually just left these in here and we just commented them out. So now we can uncomment them out, and now we have the same. We just have to put our master sheet here, master sheet PNG, and then now we'll be able to render our sprite numbers here. So we wrote that out. Let's run our script, Python 3, drawnums.py, and it ran okay. So let's check and make sure it exported. And then this will be able to tell us what our quad range is for these collidable map objects that we're about to make a class for. That's not it. It's in graphics, and it's in tiles numbered. Cool. So we've got our updated tree position here. Now, this is our cheat sheet for the quad range that our collidable map objects will be. So we can check what just happened. We can check now. We know the range, and the range is going to be 97 all the way to the end of 224. So 97 to 224 is going to be our range. Let's add that before we forget it. We'll add it to our notes. Who just farted? Jeannie farted. Of course she did. Hi, Jeannie. So, Jeannie, if you got 10 gold, you can... Actually, I didn't check if there was another skin for Rogue, but there might be. So if you got 10 gold, I think the other colors cost 10. So we can do here, we can say... and Jeannie farted right when we were gonna type these numbers in. Was it 97 to 224? Was that the range? $97 through to 224. I think that's right. Let's double check. $97 to 224. We got it. Okay. So now we have a range of values that our tile IDs are going to be if we decide they're going to be a collidable map object. So let's start writing our class for our map object here, or our collidable map object table. So we'll go here into our source, and we'll make a new file, and it'll be called, all of our classes by convention have a capital starting, so we'll call it collidable map objects.lua. This will be a class. Now, how we do this is we need to say that the title of this class, collidable map objects, is going to go ahead and get a class, empty brackets like that, and I believe that's how we do it. Then we need our 3 main functions, which will be, let's copy this. So we'll do collidable objects init, and we need a function at the beginning of this. Okay. Then we need our update, which will be okay. Well, that was supposed to be prettier than that, but our update function takes in delta time. Then we need our render function. And actually, we don't need a render function because we're not going to be rendering in this. We just need to be able to place a bunch of stuff. We need to instantiate this. This needs, like, we know we need a couple things like a self.x. We know we need a self.y. And we need a self.width. And then, so you got to do, to buy Eevee, you got to go ! Avatars, right? Buy, wait, hold on, now I'm confused. I think it's buy space avatars with an S and then Eevee, and then you can do it. And Eevee should be only 10, so you should be able to do it. It's just going to be ! Buy space avatars S, and then space Eevee. You should be able to get it. Okay. So we need to kind of decide how we need to input the width and height of any given collidable object. We could insert them manually as parameters, but that would mean that we have to manually put in, we'd have to know if something is bigger than a tile size width or height. So I think actually what we do, we hard code at least the width and height as to be 16. And we can put tile size instead. And then okay, so our collidable map objects get initialized with an X field, a Y field, a width, and a height field. And the width and height are at least set, but how do we tell it what numbers to put in our X? Hey, nice grab. We need to be able to put a reference to the X and Y. Yeah, how do we do this? The X and Y would be part of the quad, because we have a reference to, I guess let's see how we render our let's go into our maps. objects, and we see that we are rendering it at an x minus 1 times tile size plus adjacent offset x. So that's how we're placing it. But the x there is the most important part because we're actually cycling through for every column of every row. So we still need a way to tell us where these collidable objects are on the x and y field. So how might we do that? Because ideally we wanted to just say, hey, if our column ID is in our range of 97 to 224, then go ahead and insert that item into the map objects. But we need a reference to the location of it as well. So it's almost like we need to calculate the x and y of the position based on which index of the table of our map declarations we are. Because if it's the first one, we know we're 0, 0 or 1, 1. Actually, it is 0, 0, but yeah, it's almost like, hey, good for the nuggets, man. That's like how much gold you have, right? Or you got 36. Yeah, we need to be able to give the x and y. Now we do have the ability to calculate the x and y based on whatever index, like whatever this count is. We don't have, because if the count is 1, it's 1 tile size. If the count is 2, it's 2. And then by the time we hit 10, it needs to loop down. So our y needs to add a tile size amount. So is this a good way? If we put all our collidable map objects in the same range here, in that same window, then every one of them will be considered collidable, which is good, but we need to, like, for example, the tree is four sprites of tile size, width, and height, and we wouldn't necessarily need to say there's a collidable object that is a width and height of tile size times 2, for the height and width, because each individual pixel is a collidable object. So if we collide with any of them, we would just reset our place. So I'm not sure we need to decipher whether or not a collidable object is bigger than a tile size. But we also don't yet know all of the collidable objects we need to put in our game. So I'm not sure if we need to incorporate that just in case we have some oblong stuff. Hey guys, hey, I say hi too. Hope you guys are doing well. It's been a while, I know. Okay, so yeah, we do need to, let's see where we're at here. So since we moved our tree is actually being assigned the default sprite value. So we need to reassign our tree sprite, and then we'll work on seeing about implementing this collision detection for map objects, overworld map objects. Well, we'll see. If we take a look at our declarations, we can see where we put our tree, which we should actually, I think it's in our constants actually. Our constants, this is where we put our tree. So all these numbers need to be changed to our new number for our tree here. Now we can use this map to see what numbers those are. So here's the new numbers. So we know bottom left is a 129. We know bottom right is a 130. We know top left is a 97. And our top right is a 98. Okay, and then if we run our game now, we should have our tree back at least, which we do, and we got our little geckos running. Okay. So yeah, I do want to think if we want to figure out if we want to do our collidable objects based on a width as well. Now it's a little different because we'd have to hard code it and say, we'd have to say, hey, if our tile is any of these 4 indexes, then we know it's one object instead of an object in every individual sprite. So I don't know if we want to do that. It doesn't make a lot of sense to me to do it like that. And we're going to be detecting collision based on the sides. So like bottom collision, left collision, right collision, all that stuff. So if we do it on a per tile basis instead of like a per, I don't know what to call it. It's not an entity because we have an entity system that is different than this, but let's go tackle it with doing, the single sprite. And then if we want to do something different, we can always add that. But for right now, I think it's going to be okay. It's hard because it's like you want to build it for success in the future, not just working now too, but it is tough to know because we don't know the shape of our game exactly just yet. So let's go back to our MapObjects class, which we need to harpoon here. Okay, so we do need a way to determine what X and Y needs to go in here. Now, I think in order to do that, we would need to get the map row and column of our map declaration. So if we called this taking in a parameter of row and column, then our X would be, and if we think about this, since our game is 10 wide, 10 sprites wide by 8 high, then we would know that our X, and actually, there might be a better way to do this. Like, no, I think this does make sense. So like if we go, if for our row, so yeah, let me think about it. Yeah, row, so the top row, our X would need to be whatever our row is times tile size. So all it would be is tile size times row. Then our width would be the same, or our column would be the same. It would be a tile size times column. So then the tricky part is we'd have to pass in the row and column of the index of the collidable map object. So let's walk this out. Like if we're at our scene, actually let's check our map, because our map is where we need to put these objects. So here's the objects. So how do we go and say, hey, if the map row column ID is in our range, this isn't the right range, by the way, this is just like a placeholder. Like let's say if we're in that range, then we're gonna go ahead and we have access to the row and column if we do this right. So we can cycle through. So let's do a nested for loop here. And it would be for I gets 1, comma, as long as our map width. And then for J gets 1, comma, map height. Then we would check our collidables. Well, yeah, we check if we're in that collidable range. of quad values for our master sheet. So we cycle through every tile of our map. And we're asking not if row and column, but if I and j. If that ID is in the range of collidable. Nice try, aka Bob. That should work. I think I can actually spawn somebody to be Jorge. Oh, look at, okay, I didn't mean to kill him. I swear I didn't mean to kill him. Let's see if I can change his name. I don't think that's working, but yeah, I don't think I know how to change his name. But that's Jorge, guys. So beat up this guy. Okay. Yeah, if our ID is in our valid range of MapObjectCollidables, which we have to get correct, then we do have access to the row and the column of that map. So using our tile size times row and column, we should be able to calculate the X and Y position of where it needs to go, and then the tile size is the default width and height. So that might work. So let's continue to build this out, and we would have to say, you know, we would insert whatever object into this table here. So when our map gets initialized, then our maps table is set to 0, and then we're going to cycle through all of our maps, and we're going to check if the ID is in that range of our collidable map objects. And then if it is, if our ID is in that range, we're going to do a table.insert, and we're going to insert into our self.collidable, oh my goodness, self.collidable map objects table, and we're going to insert it a value, and the value is a object instantiation. So it'll be our collidable map objects instantiation like this, but it also needs an X and a Y, which we will pass in our I and our J respectively, so that it will populate the correct X and Y for wherever that ID is equal to a collidable map object. The Jorge is really cute walking over there. I'm sure there's a way to rename it. I'm just not so sure. I can figure that later. Collidable map objects, yes. So what we do also need to do is go in our dependencies, and we need to go, we don't have it harpooned, but we will do it now here. Dependencies, we need to harpoon it so we have access to it, and then we need to require our class here. So we've got a bunch of different classes, and we put it in our source folder, so we need to put it right here. We need to require our source collidable map objects, and we don't need a .lua. Lua does that for us. We just need to make sure we spell this right. Collidable map objects for our class, and it is. Now let's take a look at our other class. Make sure we do the name of the class gets a class curly brace, and that's what we did for our collidable map objects. Collidable map objects with an S gets class curly brace. So this should be, we shouldn't actually need an update function because this isn't going to change. We're just going to overwrite this depending on what map we're on. So I think that's okay. So we've got our class. Let's go ahead and see. Let's actually get our correct values here. So it is, was it our map ID would need to be bigger than, what was it, 97? and map at the ij would need to be smaller than a 244. And we have to check the ID field because that's what numbers are actually, those tile IDs. So let's make sure we got those numbers right. 97 through 224. 97 to 24. Okay. So now, by the time we instantiate a map, and that happens anytime either we start on a screen, it'll initialize a map, or we transition to a screen, it'll instantiate a new map, and we should have the ability to insert into our collidable map objects table a collidable map object that has an X, a Y, and a width and a height. So I'm curious if we take the current map and we go into, now our collidable map objects are part of our map. So if we go into our scene and we go, our scene has a current map. So our current map is the actual map instantiation that we want to check the field of to see whether or not those collidable map objects are actually being inserted. So we can do something like this where we can go print up, first of all, let's just say love.graphics.print, and we can say that we want to print up collidable, we'll just call it collidables. And then we want to actually put in, we want to concatenate that with a string value of our self.current map. That is the map instantiation. And then we go even further into that map and go to its collidable, what was it called? So we've got the map objects in our map. We've got this collidable map objects. That's what it is. So collidable map objects. And we don't want to print up, this will just print up the address of the table itself, but we want to print up, this is a table of objects. So we actually want to print up, I wonder if we can do, if we pass in the hashtag there, I wonder if it would give us the value of items that are in our collidable map objects. Now, for our current map, since our tree is the only sprite within this range of collidable map objects, so we're gonna see if we can do, we're gonna see if this prints anything. Let's see. Scene 170 is not liking this. It's, oh, right here, we just need so we need to give an X and Y to what we're printing. So that's the string we're gonna be printing. And then we would need like a, let's just do 55. Okay, map 26 doesn't like it. Let's see what's up with map 26. Okay, it doesn't like the ID field. It's because, actually, we might want to do this based on our tiles. It is based on our tiles. Our map declarations don't have a .id field. Only our map self.tiles does. So we need to do this a little differently. We need to ask if our tiles... Now, our tiles... Oh, see, and then this is a little messy too because our tiles table is by row. So tiles 1 is our top row, tiles 2 is our second, and then every subsequent index will be our next one. So we should be able to just put IJ. Yeah, I'm hoping we were able to put IJ.ID. That's what it's checking. .ID. Okay. And we can also turn these values into constants so that it doesn't have to be these weird magic numbers sitting in there. But we're hopefully going to be inserting into our maps collidable map objects table different collidable map object instantiations. So let's see if we're still crashing here. Map 26 is still crashing. So it's not our tiles, it's actually our self.tiles. Okay, let's see. Oh lordy. Okay. Self.tiles index IJ, okay. So yeah, the thing is, we are putting in an ID field. Oh, no, yeah, because as we insert a value into this table, it gains a new item, and we access that item based on the index. Like, so we should be able to do a 2D array here. I'm curious if it stops crashing if we just take out the second dimension of our array. So let's see if that still crashes. It still does. So what are we missing here? Who just did that, Genie? I should have known. Okay. You guys could try to battle royale. Austin, you have that ability. You can try, I think only mods can do it, but if you do exclamation battle royale, everyone will duke it out. And then if Jorge wins, you know, I'll owe him a drink. Okay, and the weird thing is we're doing... Oh, heck yeah. That's gonna be fun. I don't know if there's sound effects. Oh, look at that. That's sick. They all get parachuted in. Oh, that's awesome. That's so much fun. So yeah, if you're watching the channel, if you're an active chatter, you'll be added as a Pokemon here. And then if you're a follower, you can unlock more skins than the default free ones, but I forgot what the gold is for whoever wins the Battle Royale, but it's like, I think it's decent. I think it's like 20 or 30 gold. Nice health pack pickup, aka Bob. Oh my gosh, Genie just exploded. If Jorge kills me... Okay, thanks. Oh man. Oh, this is... The hell, it comes down to who gets the med pack. It really does. Oh my god, Jorge's gonna get it. Oh my god. I owe Jorge a drink. Why? And he won 50 gold. He won 50 gold and he's not even on stream. Okay, that's pretty OP. That's crazy. 50 gold's a lot. Self.tiles. See, we're able to index a 2D array of our self.tiles table here. So why is it crashing and saying it's a nil value here? And if Jorge gets a Twitch account and joins, I'll add that gold to his account. So maybe that's a Maybe that's an incentive to make a Twitch. I don't know if they were even watching though. Well, I don't know. Jeannie just farted. Maybe she was watching. Okay, so we're able, and you know what? We do kind of save it as a variable here, and then we go into the ID field. So maybe there's something unique about this where maybe we can't say a .id there. Maybe it only has the field of a one-dimensional array. I don't know if that's the case. Well, see, and then we tried that here, and when it was messed up. So what if we instead have a local tile, and our local tile gets to be our self.tiles at our I and j, just like this, and then we go tile.id, and that's what we check. If that doesn't crash us, then we learned something about Lua, but I think it's still going to crash. So let's just check. We should have something very similar to this. We save our tile as a YX, yeah, our first one, then our second one. And then we're able to access the tile ID right there, tile.id. So we should be able to do something like that. Yeah, tile ID. We get our first one and second one. That should be it. And we could do this. Let's just see. Let's see if this crashes us. Yeah, we still crash at map 26. So and what's weird is we are inserting into our self-tiles table right here. So we should have those values. So let's just comment this out for now, for the sake of it, and just say self.tiles at 1,1, just hard coding a test here, and just see if we can say local tile gets whatever this tile is. That shouldn't crash us. Okay. So there is no item in our collidables for our map. So I'm wondering if we can say now just for every... Yeah, and actually we want to do... I think we actually want to do this for a map height amount of times first. And then a map width amount of times. And then what we want to do, so this should add 80 items into our collidable object table, but we'll see if that is happening like we thought. So we're going to insert into our self.collidable map objects. And we're going to insert an instantiation of our collidable map objects. And we're going to pass in, we're just going to put, you know, 1 and 1 as the X and Y, because it doesn't matter here. We're just trying to see if we can insert, oh, and you know what? Yeah, we need to insert, we're not inserting the tile, but if the 1, 1 is the parameters we pass from our tile, then that's all we need. So let's see if that is crashing. Okay, so it does have 80, so that is working. We're able to insert a collidable map object into that table, but why aren't we able to, I guess, if we change this to be I and J, does that still screw us up? Write it out. Okay, so we're not crashing there. So how is it that we can, this is the same line as the one below it, and then if we comment this out, we say, okay, our tile gets self.tiles that, okay, and then our tile ID, and this is where it crashes, right? Right here. Let's see what line it crashes at. And you know what? It's not. Okay, so I think I know what we need to do. Our collidable objects is working, but we need to do greater than or equal to, because that 97 should be included, as well as 224 if we had it. But our tree is actually at 97, so this should give us a total of 4 collidable map objects, which it does. Okay, so now that we've got, so our map right here is a bunch of tiles that's rendering, and then it's also got a reference to a collidable map object that has an x, a y, and a width and a height. So now we just need to add in collision detection for our entity. So our Kavoth here, or our Tashio, my bad, our character here is actually a entity that has a collides with target function. So we should be able to, what just happened to Jean? Did she just, oh, she must have just left. We should be able to run the collide function on, we cycle through all our collidable map objects, and we pass in as the target every instantiation of our collidable map objects, and then we can do some actual preventing us from walking over a tree, potentially. So ideally, we're populating this correct. So for example, those 4 items that we just made should be a collidable map object in this table. And if we go at 1, that should be the first map object. Now that first map object would have an X and Y of whatever tile ID it was that was collidable. So, and then a default width and height of 8. So yeah, mine is lagging too. Did you catch another star, aka Bob? I didn't see it. Okay, so I think we could go out and print all of these X and Ys, but I think we can trust that this is going to be okay. And what we're going to do now is test. We need to cycle through, in our scene, we need to cycle through all of our collidable map objects and pass in that object itself as the target to check collision for our entity. So our entity is our Tashio player. And if we take a look at here in our entity class, we have a collides function that is basic AABB collision for the square. So let's test this out, and we'll go into our scene. And we want to render something, right? We want to render like a signal that the collision's working. So we want to change the tile that we're colliding with to become red once we're colliding. So we'll see what we can do with that. So we'll see if we can say, ultimately we have to cycle through all of our collidable map objects. So how we do that is we can say for I gets 1 for the number of self, and this is actually in our scene, so we have to go to our self.currentMap.collidable map objects. So this should do, at least for our current map, is 4 collidable map objects. So that should be 4 different things. Let's see. Let's just make sure that's working. It should be love.graphics.draw, and what we want to draw, .print, and what we want to print is the index of whatever. So we'll say index concatenate with the actual I value. And then we can say that the X and Y is just a 5 and a 10. Let's see. Okay, so we need to make sure our Y is actually we could do a 10 times our I, or we would do a 10 plus in I times. We want to shift it down by 10 every I. So we would say I times 10. 10 plus in I times 10, or just in I times 10. Okay, let's see that. Oh my goodness. Okay, so we do have access to those index, so we are able to do the hashtag print there to give us, that just proves that we've got the 4 items from our collidable map objects in our scene here, as long as we dereference the current map here. Then, so we're doing that a certain amount of times. We're doing that for a collidable map amount of times, but what we want to do is check our collision. So our self.player is the entity that we are, and we want to check if it collides with a target. Now the target we want to check is the actual object of the current map in the collidable map object table at the ith index. So that's a little crazy, but it should make it so that we can say map object and then we do an index of our I. So I'm hoping that will run the collision detection for every collidable map objects on every actual object in that table. So what do we want to print if it is colliding with that thing? We want to hopefully render the tile that it is colliding with to be perfectly red. So how would we do that? We would say something like, if we go to the beginning here, when we can say if self-player collides with any of those objects, then we would want to, and we have access to the X, Y, and width, the height of those collidable objects. So what we can do is do a love.graphics.setColor, and we should have red. I believe we have a red as a constant. We do right there. Okay, so we set the color to red, so it'll be red when we render it, and then we want to do a love.graphics rectangle, and the rectangle takes in a property of fill or line, but we want to fill it, and then an X and Y width and height. So all we have to do is put, and this is really verbose, but there is a way to put self.currentMap.collidable map objects at that position, and then we index our X. So we would need this for our Y and width and height. Now I'm curious if we can split it up like this so that it's a little more readable, so it doesn't go off screen. So we would give it its X right here. We would give it its Y right here. And then we would need its width. What just happened? Y right here. Width right here. And then height. And then hopefully, this shouldn't stop us from walking over the tree, but it should render a red square on the tile that we are colliding with, granted if we did our collision detection correct. And then we need to close our rectangle function. Let's see if that works. Okay, it put a red square way over there. So our collision detection is jacked. Now we are only testing if it collides, so we're only rendering this because our collides actually returns true. Let's just flip this and see if that changes. Okay. I don't see. Okay, so we need to do something. We need to just test this collision function a little better because I don't think it's working. In our entity class here, let's just redo this from scratch. And we'll see. So we've got a self.x position, right? Yeah, x and y, okay. So we would want this function to return true if we're colliding and false otherwise. So we can say if our left side of us is greater than the target's x plus the target's width, and the right side of us, so x plus our width, is smaller than the left side of our target. This is for non-collision, so we'll return false if this is the case. And then we can do this and say, then if the top of us, self.y, is greater than the bottom of our target, so a target.y plus a target.height, and the bottom of us, self.y plus our self.height, would be smaller than the top of our target. And if all of those are true, then we need to return false. And then we can say we need an if here. And we can say if we just return true otherwise, we don't want it here, we'd want it, I think we would just do a return true down here. Okay, so let's see if that changes anything. No. We still got, see, why is our x and y over here? The square shouldn't be way over there. I'm not sure why it is. But that looks like our entity collision detection is functioning the same as it ever was. Okay. The x and y of our collidable map objects are incorrect. So if we take a look at our collidable map objects, now our x is being saved as whatever row times 16, which is our tile size. Is that right? If the row is 1, oh, see, row is going to be y. Yeah, column, I think these should be switched. Okay, because our x position depends on our column, and our y position depends on our row. I think that's right, but I still don't think that will be... It's still off. So we're still detecting a collision for no reason, and we're still rendering it in the wrong spot. Okay, so let's just return false only if we're not colliding, and then we'll... I guess that means this would be nil if we don't... Let's see if that crashes it. Well, we're colliding, so it shouldn't. For whatever reason. But if we switch this in our scene, if we switch this to be a not collides, let's see if we crash. Okay, I'm not sure. It's just that this, and what's weird is like, so it is rendering, oh no, our stream just crapped out. Crap. Reconnecting in 8 seconds. Crap, dude. That's not fun. Okay. Sorry about the crash, guys. I don't know what it is. We were doing good. Okay. Yeah, sorry for the crash, guys. I don't know what's going on. Oh my gosh, Sypha's barking like crazy right now. It's kind of distracting. So the fact that we're rendering a 4 tile size rectangle tells me that our X and Y is somewhat correct. Like we're rendering it, you know, we're rendering 4 objects all right next to each other, you know. So, you know, yeah, we're at 60 FPS. We just dumped down to 0 and crashed. I don't know why. If we were to put let me try something else. If we were to put just 0 and 0 in here, we should only see 1 tile worth of red. Yes. So we are messing up the X and Y of these collidable objects. Let's walk through and make sure we're understanding it correctly. So our collidable map objects. Okay, so we pass in the row and column of our map for our X and Y to be updated. So if we go to our scene, we actually want to see, it's actually in our map. This is where we're instantiating it, and we give it an X and a Y, or a row and a column as far as the parameters are concerned. And it's so our nested for loop here starts with our rows, and then J's our column. So that should be right. Now, the ID, okay, so yeah, wherever the ID, whatever tile ID of the row that is a collidable map object, which is our tree, is getting passed into our collidable map object. So this should be the row. Okay, so yeah, let's look at it and see. Actually, what we can do is print up what these values are and see what discrepancy is happening. And it looks like it's just off by 1 pixel. Oh. So if it's 1 pixel to the right, okay, I know what it is. Yeah, we just have to, in our map objects, we do a tile size times column, but we need to, it's going to be 0, 0, so we need to, how do I explain this? Yeah, we just need to subtract a tile size because of the index. So like row in column 1, 1 should print it up at 0, 0. And then that's why we need to subtract a tile size, because 1 times a column would be 16, not 0. So we just need to subtract the tile size and then we should be correct. So let's see, we should see red where the tree is. Okay. So we've got red where the tree is, and we're rendering that on a per tile basis. But we need to, as soon as you win, you go straight to the slots. How predictable. Dude, and you win. Hey, congrats. I'm proud for you. How much did you win there? Hey, 15, not bad. Hey, I want slots. Did it work? Okay. Okay, so now we need to fix our collision detection function, because it should only be rendering this red if we're colliding with it, not all the time. So once we figure that out, we'll be in business. So let's go back here, and at least we've got that. Okay, so it's our function here that's jacked. We're doing that in our scene. So this collides is always returning true. So let's go to our entity. Now our entity, I'm trying to think if it has to do anything with the state machine. I don't think it does. Okay, well, we need this to be better. Let's say if our left side, let's do this for a return true instead. And we'll say if our left side is smaller than the right side, and our right side is greater than the left side of our target, then if the top of us is smaller than the bottom, and the bottom of us is greater than the top of the target, then we're going to return true. Let's see if that changes anything. It doesn't. I mean, I didn't think it would, but it's like, it's only ever returning true, so it's detecting a collision all the time. Or if it's just not returning false, we could say else return false. And then else return false. And maybe Maybe that'll stop it. We're still rendering it no matter what. Let's double check where we're rendering this and make sure we're not like misunderstanding something. It should be in our scene. Now we only render this if we're colliding. Oh, hold on. We're not updating this. But I'm curious if this is just, I mean, we shouldn't be colliding with it, so it shouldn't render in the first place, is the thing. But because as far as our function's concerned, this is a target, right? It's a parameter target which has a field x, y, width, and height to check against. And we're checking all of those objects. So, oh, is it really? We lose an hour tonight? Okay. I think I'm gonna do, let's see. I don't know. Everything I want to test is just like requires a bunch of things to try. So I'm trying to think of a good way to test this collision, but okay. Let's just sit down and do it because we have to figure this out. Yeah, hold on, guys. My dog's going crazy. I gotta just check on her. I think I'll update it so that I'll put the stars on the Be Right Back page too. Right now they're just, oh dude, that was a 2-star catch. That was awesome. I'll put the stream avatars on the other pages so that I can be at the Be Right Back screen and you guys can still play. Okay, so what we want to do here, we want to just test this function, right? So what we want to do is we'll turn this all off for now. And we want to give us like a dummy value, a dummy collidable map object. So if we go into, and actually we don't have to, what we can do is give it to us here in the scene. We can just say self.object. And the self.object gets a map collidable or collidable map objects instantiation, and the x and y is a 0, 0, and the width and the height is already set. So we should have collidable map object at our very top left of our map. And then what we can do, instead of doing all this, we can just print out the value of the collision function here. Now, part of me thinks that since we're only doing it in the render scene, that it might be messing something up instead of the update, but I also don't think that really matters. So let's just see. Love.graphics.print. And we want to print the value. So we'll say collide, and then we'll concatenate to a string that is the value of our self player collides function with the target of our self.object, which is in the top left there. So I'm hoping this will be false when we spawn because we shouldn't be colliding with it, but it'll probably be true because we're rendering that object incorrectly. So let's see, 5 and 10 on the X and Y. Now let's see. Okay, 184 on our scene, we're crashing. 184. Okay, we're just missing, we're missing this. Parentheses. Yeah, see, we're detecting a collision all the time, which is incorrect. So let's print up the values of this object to just make sure that it's what it's supposed to be. So we'll print up the X, Y, and width and height of this self.object and make sure that is what we're supposed to. So we're gonna say that this is, yeah, the object's X, Y, width, and height. Okay, and then we want this to be, this is a string and then an X and a Y. Why are these? There we go. Okay, so this is 25, 35, 45, and 55. So it should be printing the X, Y, width, and height. Okay, well, that's the first error, is that the X and Y are incorrect. It should be 0 here. If we give ourselves a collidable map object at a different X location, let's see. Let's say not at 0, 0, but at tile size, that should be like the 1 pixel over, 1 pixel down. It should be, but then the values that we're actually going to be printing is going to be 240, 240. Okay, yeah. Our X and Y is jacked, so we need to do this better. Yeah, we need to do this much better. Let's, because this should be unchanged. Oh, and you know what? We passed this based on a... The reason that's so big is because we're supposed to only pass in not the X and Y, but the tile X and Y. So like a row and column 1, 1 should translate to 0, 0. So we'll see if that's the case. So 1, 1 should be 0, 0 in here, which it is. But that's actually not right either. Well, no, I think it is right. Because if we wanted, let's say, row 1, but column 2, it should be an X of 0, but an X of 16 and a Y of 0. So let's see if that is true. X of 0, Y of 16. So those values are correct. but our collide function is still only returning true. So that's what's wrong about it. Now, it's in our entity class. Now we're returning false if it doesn't collide with anything. So what are we messing up here? If the left side of us is smaller than the right side of the target, and the right side of us is greater than the left side of the target, then if the top of us is smaller than the bottom of the target, and the bottom of us is greater than the top of the target, return true. Okay, so here's what I'm gonna do is comment this out. We're gonna detach, we're gonna go, we're gonna get clone the repo for http://github.com, and it is CS50. What is the repo for games50/zelda.git? That was it. Okay, so we're gonna go into the Zelda repo. We're gonna take a peep around. We're gonna check their entity class. Whoa, 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 that freaked me out. Hey, thanks for the follow. Flan must die. Yeah, welcome. So if you chat in the chat there, you'll get a little Pokemon on screen if you want. Yeah, Flan must die. Welcome. We are building a top-down adventure game. I'm looking for the entity class, and then I'm looking for the collides function. So this is how they do it. And they return the value, the opposite value of the checking of the collision. So let's just see if that would help us, and then we'll see if that's a better way to do it, which if it works. And I just deleted my buffer, so we need to go back into NeoVim. And you know what? What we can do is add this as another tmux session. So we could do tmux, new session, call it Zelda, and then now we can NeoVim into it, and we can go into the entity class. And then we want to, this is ours, so this is not right. We want to go up in directory, cd git/Zelda, and nvim here. And we'll go to the entity class, we'll go to where they do the collision, and we'll yank this, and then we can swap our tmux so that we're back in ours, and then go put this in our entity class and paste it. Why? Okay, let's try it again. Okay, so swap. We're gonna yank this. We're gonna swap back, and we're gonna paste it. And, okay, something I'm not understanding about this. Let's try a leader yank, and let's see if that works. And then we'll swap, and then do a leader paste. Still didn't work. Okay, here's what we're gonna do. We're gonna split our window. go into the Zelda repo. Yeah, thanks for the follow. I really appreciate it. We're trying to get 40. We're doing real good. So here is the function. So this is like saying the right side of us. The right side of us is smaller than the left side, which would be not a collision. Oh, okay. That's okay. Hey, I appreciate it. Oh, what Pokemon are you? Oh, you're a little Senchet. That's the first Gen 2 on the stream. Hey, thanks. Thanks, man. I appreciate you being here. This is fun. So you can make your little guy dance. You can move him, so you can do dot dance to make him dance like that. You can make him move. You can make him attack stuff. And then whatever your favorite Pokemon is, we've got Gen 1 and 2 on stream avatars, and it is it's 30 gold to buy. So you get 1 gold every 2 minutes, I think. But what I can do is I can do a currency add Flan must die, and I can give you 50 gold. So now you can go buy whatever your favorite Gen 1 or 2 Pokemon is, as long as it's not a legendary. You can buy it by saying buy avatars in then whatever Pokemon you want. If you're into Pokemon, I don't know if you're into Pokemon, but you could do buy avatars, whatever Pokemon you want, and if it's I think it's 10 for first evolutions, 20 for second, 30 for third evolutions, and then legendaries are more expensive, but there's that. So we're seeing that the right side of us is smaller than the left side of the target, or if the left side of us is greater than the target's X plus its width, so the right side of it, or if the bottom of us, see, instead of returning true or false, it returns, hey, you're welcome. You're welcome, Flamastai. So if you're not into Pokemon, there's some Marvel characters. They cost 30 gold, I think, but you should have enough to buy one of those if you want. If you use the Stream Avatars extension, you could see which guys are available, but there's like Iron Man, Deadpool, Hulk, Cable, Hulk, Target.y. Okay, so instead of returning false or true, they're returning a Boolean of this question, which is a more concise way to do it. But I don't get why ours wouldn't work. Let's try this. We're now using their entity system, or their collision detection system in our entity class. See, and we still get collide is true no matter what. So I'm wondering if this is a issue of doing the collision detection in the render function instead of in the update function. So I know you can print up other values, like you don't have to, huh. Yeah, I don't know why this is happening. Okay, so we're seeing if the right side of us is smaller than the left side, or the left side is greater than the... Oh, well, this is wrong. And then the bottom of us is smaller than the top, or the top of us is greater than the bottom of them. And we return the opposite of that. So all this condition is if we are not colliding, and then we say return not colliding. So it should return true if we are colliding. Hey, Bitwishak. Hey, good to see you. Thanks for chatting it up. I believe you should have a little Pokemon on screen now for chatting. What is that? What are you? What is that? Oh, is it it's a Kabuto. Yeah, okay. I didn't know what Pokemon that was. I had to squint at that thing. Yeah, you're a little Kabuto. That's really cool. I haven't seen that guy on stream yet. Here, I'll chuck some more stars. So if you do exclamation point jump, you could jump to try to get those stars. But thanks for the first time chat, man. I appreciate it. We're just building a game here. We're trying to figure out collision detection, which we are having some issues with. Yeah, it still says collide is true, no matter what. Okay. Yeah, we are not figuring this out so well. I guess one thing it could be is that, like, I really want to kind of just, I think we'll, like, if we could make our character be on our mouse pointer, and then we can kind of just like move it to test these collisions. Well, our collision detection function is only returning true. Like it's only ever returning true, so it's just not right. And we've tried it two different ways. I tried to write it, and then I tried borrowing the function from an example. So like if we just return false here, it should say false instead of true. Oh, it still says true. So maybe this is part of the issue, because like entity collides target, we should be returning a true, but we take a look at our scene. We're rendering whether or not the player collides with a self.object, which is an object we have at the top left of the screen. And that's always true, but that function should only ever return false. So now I'm extra confused. So I think what I want to do is in our update function, we're just going to give ourselves a collide variable, and we're going to put our self player collides with this object into that collide variable, and we're going to try updating it and see if that fixes this issue. So our collide, hey, have a good night, aka Bob. Thanks for joining, man. Yeah, give it one last go on the slots, call it a night. Thanks for watching, dude. I'm wrapping it up here soon too. Okay, so we're storing the result of the function 60 times a second into this. Yeah, so we've got Well, so we're on it right now. I'll show you the if you look, I think my about profile's got my GitHub, and you can go. It's the repo is called Tashio, Tashio, and our collision function's in that repo right now. So you can check that out if you want to peep at it right now. But I'm working on fixing it now. So if you want to take a peep at it, you could look at it on there. But we're trying to fix it right now. So yeah, we're storing the result of that collision function into this variable, and then we're gonna print up the results of that variable here. And now let's see if that makes any difference now that we're updating it. See, this shouldn't be true at all. It should be false because we're manually telling it to be false. So, hey, yeah, good night, AK Bob. Love you too. And Holden too. And Holly. Yeah, this is just really strange that we can return false and have it be equal to true. So like, that's not making any sense to me. Let's make sure in our scene when we instantiate our player that it is in fact an entity, which we pass it to our scene. Yeah, maybe this is the issue, is our player isn't even inheriting the entity class. So yeah, that's exactly what the issue is. Our player isn't actually an entity. I mean, I think our player class, where's our player? Our player class here inherits the entity, so it is an entity, but I don't know if we're updating. We're updating the entity here. Oh, well, so we've got... Okay, so this is probably what's wrong. We've got a collides function for our player class, not our entity, that is probably overriding our entity function. So let's just see if we take that out, if we return false now on the collision, and it's a nil instead of false. So that's at least one step in the right direction. Now, we do want to be able to check all entities for this collision. We don't want to just do... yeah, exactly. Little gremlin bugs. And so, like, yeah, my friend tells me programming is like a murder mystery where you're the victim, the murderer, and the detective. So, like, that makes so much sense, because it's like, it's all my fault because I typed all this stuff. But I'm also the victim. I did it to myself. Okay, so I think what we want to do is just, we don't want our player to have a function called player collides. Yeah, that was, it was like a meme he sent me that like that, and I thought that made so much sense. Let's see if we're nil if we take out that function altogether. Oh, great. Now we're false. Okay, so let's take out the false from our entity class now, and we'll see if the collision detection is actually working. So instead of returning false, we're going to go ahead and turn this back on, which is return the opposite of the not collision. And then we'll see our self.object in our map is up here. Okay, looks like it's working because we put it Well, it's almost right. So like the collide, let's take a look. Our collision should be in our map, and it's at a self.object, and the self.object, let me see. It's in our scene. Okay, so let's give us 1-1 would be the very first grid, so the very top left. So we're gonna see if we're colliding with the top left now. So no collide, no collide. If we're in that top left, yep. So as soon as we go in that top left, we're there. Okay. So now that that function's working, can we get the tree? We want any collidable object, which right now the only ones are in this tree. If we collide with it, we just want to turn it red, and that's all we want to do for right now. If we can get that done, then we can call it a night and we can tackle more tomorrow. But let's see. In our map class, now we insert a collidable map object into our maps collidable map objects table. So this is the range for those collidable objects. So now that we are inserting it into that, we should be able to go into our scene, and instead of just doing this, let's take this out, and we want to insert our old logic back in, which is we cycle through all of the map objects we have, which is 4 because the tree is made up of 4 tiles. Then we're going to check if that player collides with any of those instances of collidable map objects. And if it does collide with any of those map objects, we're going to set the color to red and render a red square only in the tile that we collide with, hopefully. Let's see. That's exactly what we wanted. So if we're colliding with it, it is highlighting. Now, we can't really just collide with the bottom one. And there's a bug. Look at us. We're not holding any directions, but we're walking still. So we need to figure out where that bug came from. It stopped once I think it has something to do with the transition. Something to do with the transition logic when we're holding in inputs. But do you see how we're colliding even though we're not actually touching? It's because we're doing true AABB collision, and the squares, our square is just a little wider than it looks, so we might need to do some shrinkage there. But our collision function is working, and what this also proves is that we're able to kind of define a number range that has all of these collidable objects. And as long as we place anything that can't be walked on in that range in our map sprite, then anytime we populate our map, we walk from a scene to a new map, it will actually make a table of all the collidable objects in that scene. And right now, all we're doing is detecting collision and rendering a square where that is. But it just proves that if we were to move this tree anywhere else, it would go there. And if we were to add any other, like a tree stump or a fence, to the map atlas right next to this tree, anytime we would draw a tree or a stump or a fence or a wall, they would also be able to check collision for those. So I think that leaves us in a good spot for tomorrow. We'll want to do some shrinkage for that collision. So what we'll do is we'll just leave us a note, and I should have gone into our notes here. We'll leave us a note saying, find animation bug for walking through a transition. well, we want to find that and smush that bug, and then we want to shrinkage for our collision detection so that it only detects a collision if we're actually touching, not just the AABB, but that's kind of the downfall of AABB. So hopefully things are pretty rectangle when we draw them. And then we will add everything to the staging area. And I need to move all of that stuff. So I've got it, and then we want to commit with a message saying we added collidable map objects, and we want to be this in the present tense, so say just want to say map object collidables with collision detection. Okay, and we'll get push to our origin main repository. Okay, so yeah, tomorrow we'll be hopefully limiting the movement so that we detect a collision, and then we make it so that we can't walk over it. We would move our position so that we can't just walk over the tree. Now that we can detect collision with the tree, we need to add the appropriate response. So there's that. Now, thank you guys for watching. That was really fun. I have a lot of fun doing this. I'm a newbie, but I have a lot of fun doing this. What I'm doing is setting up a raid for anyone who wants to go check out Practical NPC, who's another game dev. I always like to raid him because he's nice to me and he's working on some cool stuff for his original indie game. So go give him some support if you want to. And I'll be here tomorrow around 7 to stream, but I'll catch you guys later.